Hello friends, myself D R Patil. Today we shall solve numericals on potential due to point charges, work done and potential due to a dipole. First question, consider three charges placed at three corners of a square of side x meter. Let A, B and C, D be the vertices of square. Three charges, 5 microcoulomb, 4 microcoulomb and 6 microcoulomb are placed at three corners of a square respectively. Then what is the charge at fourth corner to be placed so that potential at the center of square is equal to 0. To find the center of square, join AC and BD, and O is the intersection of these diagonals and O is the center of the square. Given that Q1 equal to 5 microcoulomb, Q2 equal to 4 microcoulomb and Q3 equal to 6 microcoulomb, and potential V at O is equal to 0. Potential V at O is equal to 0. From the figure, AC is equal to BD is equal to root 2 into x, where x is each side of a square, and AO is equal to BO is equal to CO is equal to DO, and that is equal to half of AC or BD, that is root 2 into x divided by 2, and that is equal to 0.7071 into x. And we know that potential at a point due to a system of charges is V equal to, or potential at O, V equal to 1 upon 4 pi epsilon naught into Q1 upon AO, because potential is given by KQ upon R, that is Q1 upon AO plus Q2 upon BO plus Q3 upon CO plus Q or Q4 upon DO. This is the expression to find potential due to a system of charges, and given that phi O equal to 0, potential at O equal to 0, hence 0 is equal to 1 upon 4 pi epsilon naught is 9 into 10 to the power 9 in the bracket. Q1 equal to 5 microcoulomb. Microcoulomb is taken outside common. 5 upon 0.7071 into x plus Q2 equal to 4 divided by 0.71, or here given that AO equal to BO equal to CO equal to DO equal to 0.7071 into x, and we can take it as common. Therefore 9 into 10 raised to 9 divided by 0.7071 into x into 5 plus 4 plus 6 plus Q4 Now 9 into 10 raised to minus 6, or right here 10 raised to minus 6, that is microcoulomb. 5 microcoulomb, 4 microcoulomb, 6 microcoulomb, Q4, that is in microcoulomb. Now 9 into 10 raised to 9 divided by 0.071 into 6. On left side multiply with 0, it becomes 0. Therefore remaining 5 plus 4 plus 6 into 10 raised to minus 6, that is equal to 5 plus 4 9, 9 plus 6 15, 15 into 10 raised to minus 6 plus Q4. 10 raised to minus 6, it is not related to Q. Therefore it can also be written as free from Q4. That is 5 into 10 raised to minus 6 plus 4 into 10 raised to minus 6 plus 6 into 10 raised to minus 6 plus Q4. Q4 to be calculated. What is the charge at fourth corner of square? And this term becomes 0. Remaining 5 plus 4 9, 9 plus 6 15, and 10 raised to minus 6 is common. Therefore 15 into 10 raised to minus 6 plus Q4 is equal to 0. Therefore Q4 is equal to minus 15 into 10 raised to minus 6 coulomb, or that is equal to minus 15 microcoulomb. Therefore if a charge of negative charge of 15 microcoulomb is placed at the point D, then potential due to all the charges at the center of square is equal to 0. Pause the video and note down. Second question. A dipole having negligible length has plus Q minus Q. It is a dipole having negligible length. Has dipole moment P equal to 4 into 10 raised to minus 9 coulomb meter. Then determine potential due to dipole. First, potential due to dipole on axial line at a distance 30 centimeter from the midpoint O of dipole. Number 1, on axial line at a distance of 30 centimeter. Number 2, on bisector or equatorial line at the same distance. And number 3, on a line making an angle (60° with dipole axis. Let P be a point at a distance 30 centimeter from the center of dipole. And potential at any point due to a dipole is given by phi equal to 1 upon 4 pi epsilon naught into P cos theta upon r square, where r is the distance of the point from the center of dipole, or it can be written as phi equal to kp cos theta upon r square, where k is equal to 1 upon 4 pi epsilon naught. Here given that P equal to 4 into 10 raised to minus 9 coulomb meter and r equal to 30 centimeter, convert it in meter, that is 30 into 10 raised to minus 2 or 0.3 meter. Therefore, number 1, on x, this is general formula for potential due to a dipole. Number 1, on axial line, theta is equal to 0 or 180 degree. 0 or 180 degree. This is the dipole moment. It is from negative to positive, and this is the potential. Point P is on the side of negative side. Therefore, the angle between them is 180 degree. Or if the point P and the dipole moment are in the same direction, then angle between them is equal to 0. Therefore, for an axial line, theta equal to 0 or 180 degree. Therefore, phi equal to potential due to a dipole on the axial line is equal to plus or minus. If theta equal to 0, then phi equal to plus 1 upon 4 pi epsilon naught into P upon r square. If theta equal to 180 degree, then cos theta equal to cos 180 equal to minus 1, hence it is minus 1 upon 4 pi epsilon naught into P upon r square. It can be written as phi equal to plus or minus 1 upon 4 pi epsilon naught into P upon r square. That is equal to plus or minus 1 upon 4 pi epsilon naught equal to 9 into 10 to the power 9 into dipole moment P is 4 into 10 raised to minus 9 divided by R equal to 30 centimeter or 0.3 meter. That is R is equal to 0.3 meter and R square equal to 0.3 square. That is equal to 10 raised to plus 9, 10 raised to minus 9, that is equal to 10 raised to 0 equal to 1. Hence 9 into 4, 36 plus or minus 36 upon 0.3 into 0.3 equal to 0.09 and 0.09 can be written as 9 into 10 raised to minus 2 and that is equal to 9 4s are 36 into 10 raised to plus 2 or that is equal to 400 volt because volt is the unit of potential and potential difference. Now number 2, potential on the bisector of a dipole and for a point on bisector theta is equal to 90 degree. Bisector line theta equal to 90 degree. If theta equal to 90, then from this equation cos 90 equal to 0, therefore this whole term becomes 0. Theta equal to 90 degree, therefore cos 90 is equal to 0. Therefore potential at any point on the bisector or equatorial line of a dipole is equal to 0. Number 3, on a line making an angle 60 degree, this is the line, it makes an angle 60 degree with the dipole axis. In this case, for theta equal to 60 degree and cos 60 equal to 1 upon 2 or 0.5. 1 by 2 or 0.5. Using the relation, that is potential on a line making an angle 60 degree, that is phi equal to 1 upon 4 pi epsilon naught into P cos 60 and P cos 60 equal to 1 by 2 or P cos 60 degree upon R square, that is equal to 9 into 10 to the power 9 into P is 4 into 10 to the power minus 9 into 0.5, because cos 60 equal to 1 by 2 or it can be written as 0.5 upon R square. Here R equal to 0.3 meter and its square is 0.09 or right 0.3 whole square, that is equal to 9 4s are 36, 36 into half, that is equal to 18 over 9 into 10 to the power minus 2, that is equal to 9 1s are 9, 2s are into 10 to the power plus 2. That is equal to 200 volt. Hence, potential at any point on the axial line is, for that, theta equal to 0 or 180 degree, and potential due to a dipole on any general point is given by phi equal to 1 upon 4 pi epsilon naught into p cos theta upon r square, and it is equal to plus or minus 400 volt. And for a point on the bisector, theta equal to 90, hence cos 90 equal to 0, hence potential at any point on the bisector or equatorial line due to a dipole is always equal to 0. And potential at any point on a line making an angle greater than 0 and less than 90, it lies in between 0 and maximum value, that is 400 and 0. Therefore, potential at a point on the line making an angle 60 degree is equal to 200 volt. Note down. Next, two charges 1.5 microcoulomb and 2.5 microcoulomb are 30 centimeter distance apart. They are separated by 30 centimeter. Then calculate potential at midpoint of the two charges joining, and also calculate electric field at that point. And potential at a point due to a point charge is given by K Q upon R. Here the distance between two charges D equal to 30 centimeter, and that is equal to 0.3 meter. Therefore, the distance between first charge and the midpoint O is half of this. Therefore, R is equal to 0.15 meter. R equal to D upon 2. Similarly, the distance between 2.5 microcoulomb and the center is also 0.15 meter. Therefore, potential at O is VO is equal to K, here K equal to 9 into 10 to the power 9 into first charge Q, or you can take the sum of these two potentials due to at I. Hence, 9 K equal to 9 into 10 raised to 9 Q1 upon R plus Q2 upon R. Here R is the distance between the point and charge at A, and the distance between point and charge at B. Hence it can be written as 9 into 10 to the power 9 upon, here R is common and R equal to 0.15 in the bracket Q1 plus Q2. Q1 is 1.5 microcoulomb plus Q2 is 2.5 microcoulomb. It is common, that is 10 raised to minus 6. That is equal to 1.5 plus 2.5 is equal to 4. 4 4 into 36. 4 into 9, 36 into 10 to the power 3 upon 0.15, and that is equal to 2.15 2s are 30, 6 4s are 2.4 into 10 to the power 3 volt. Volt is the unit of potential. Now, electric field at O due to charges at A and B. Electric field is given by E equal to K Q upon R square. KQ upon R square. Here R is the same and Q1 and Q2 are the same. Therefore, for system of charges, electric field is given by K into Q1 upon R1 square, that is R square, plus Q2 upon R square. But here both the charges are positive, therefore there is force of repulsion, therefore direction of electric field is away from each other. Hence, plus becomes minus, that is Q1 upon R square minus Q2 upon R square. That is equal to 9 into 10 to the power 9 upon R square. In the R square is common, therefore Q1 minus Q2. That is equal to 9 into 10 to the power 9 upon 0.15 square. Q1 is 1.5 minus 2.5 microcoulomb, that is 10 raised to minus 6. That is equal to 9 into 10 to the power 9 minus 6 10 to the power 3 upon square of 0.15 is 2.25 into 1.5 minus 2.5 is equal to minus 1. That is equal to 9 divided by 2.5. 0.25 equal to 4 minus 4 into 10 to the power 3 volt per meter or Newton per coulomb, because the SI unit of electric field is volt per meter or Newton per coulomb. Here negative sign indicates that field is in the direction from B to A. And next, For magnitude of electric field at O is equal to 4 into 10 to the power 3 volt per meter or Newton per coulomb. Now, fourth, three charges 5 nanocoulomb minus 5 nanocoulomb and 10 nanocoulomb are placed at three corners of a square of side 2 meter. Let A, B, C, D be a square of side 2 meter plus 5 nanocoulomb minus 5 nanocoulomb and 10 nanocoulomb are placed at the corners A, B, C respectively. Then determine the work done in bringing a charge 3 nanocoulomb from D to the center of the square. To find the center of square, draw diagonals AC and BD. Now O is the midpoint of the square. And if 2 meter is side of each square, then its diagonal is equal to diagonal AC is equal to BD is equal to 2 root 2, side into root 2 meter. Then find potential at O due to charges at A, B, C respectively. Then find potential at D due to the charges at A, B, C at D. Now first find potential at O, and potential at O is equal to 1 upon 4 pi epsilon naught in the bracket Q1 upon AO plus Q2 upon BO plus Q3 upon CO. There is no charge at D. Then find the potential at O, and that is equal to, here AO equal to BO equal to CO, since O is midpoint of the square. Hence AO equal to BO equal to CO equal to DO is equal to half of BD or AC, that is equal to root 2. And 1 upon 4 pi epsilon naught is equal to 9 into 10 to the power 9. Here all these are constant, constant, and it can be taken as common, that is AO, and AO equal to root 2 or root 2 equal to 1.414. Right here AO is equal to BO is equal to CO is equal to DO is equal to root 2 upon 2, that is equal to root 2, or root 2 can be written as 1.414. It is taken as common in the bracket Q1 is 5, Q2 is minus 5, that is minus 5 plus 10 into nanocoulomb is common. That is equal to plus 5 minus 5 0 plus 10, that is 10 into 9, 90 upon 1.414. Here 10 raised to plus 9, 10 raised to minus 9 get cancelled. Hence 90 upon 1.414 is equal to 63.64 volt. Here volt is unit of potential. Now find the potential at D due to these three charges. And potential at D is represented by Vd. That is equal to, formula is same, that is 1 upon 4 pi epsilon naught equal to 9 into 10 to the power 9 in the bracket Q1 upon AD, this distance, then Q2 upon BD plus Q3 upon CD or DC. First write, that is Q1 upon AD plus Q2 upon BD plus Q3 upon CD. That is equal to 9 into 10 to the power 9. All these are different. BD is different from AD and CD. Therefore, you can't take outside constant. Hence write, but Q1 equal to 5 upon AD equal to 2 meter plus Q2, but Q2 equal to minus, hence minus 5 upon BD equal to 2 root 2 or 2 into 1.414 plus Q3 equal to 10 upon CD equal to 2 meter. That is equal to into 10 raised to minus 9. That is 5 into 10 raised to minus 9, 5 into 10 raised to minus 9, 10 into 10 raised to minus 9. 10 raised to minus 9 is taken outside. Here 10 raised to plus 9, 10 raised to minus 9 get cancelled. Remaining 9 into 5 upon 2 is equal to 2.5 minus 5 upon 2 into 1.414 is equal to, use calculator, 1.77. 1.77 plus 10 upon 2 equal to 5. That is equal to 5 plus 2.5, 7.5, 7.5 minus 1.77 is equal to 5.73. That is equal to 5.73. 9 into 5.73, and that is equal to 9 into 5.73, that is equal to 51.73 volt. Therefore, there is a difference between potential at O and potential at D. Hence, work must be done in bringing a charge of 3 nanocoulomb from D to O is given by. Therefore, work done on 3 nanocoulomb charge to bring it from fourth corner, that is D, to the center is given by W, work done in moving a charge from point D to O, is equal to charge into potential difference. Potential difference, that is equal to, here charge given is 3 nanocoulomb, that is 3 into 10 raised to minus 9 into potential difference between D and O. Potential at O is greater than potential at D. Hence potential at O minus potential at D, and that is equal to 3 into 10 raised to minus 9 into potential at O is 63.64 minus potential at D is 51.73, and that is equal to 63.64 minus 51.73 is equal to 35.73. Hence 3 into 35.73 into 10 raised to minus 9, and it is found to equal sorry 1.93. This is 63.64 minus 51.73 is equal to 11.93. 11.93 into 10 raised to minus 9, and 3 into 11.93 is equal to 35.73 joules. Joule is the SI unit of work.